Hey class, welcome back. Today I hope you're excited. We're moving on from factoring. Factoring is probably the largest section of this entire chapter, and so good news, we're moving on from that. Today we're going to be learning the third method for solving a quadratic function. The first, just to recap, was by graphing. So wherever your parabola across the x-axis, those were your two roots, okay? That would be solving a quadratic function by graphing. The second method was just factoring. So we had that list of 4 steps to follow in order to factor something. Today we're going to be covering the square root method. So there are only 2 parts to this lesson, unlike the factoring where there were like 6. There's only 2 parts. The first part today, I'm going to teach you some of the basics of some square roots and radical expressions, just so that you know how to deal with them. And then in the second part of this lesson, I'll teach you how to actually solve the quadratic functions by using this method. So today, in your notes, we are in the part where it's headed solving quadratic functions by using the square root method. So a couple things that we want to cover first. The symbol, oh, I still got my highlighter on. Okay. This symbol, a lot of times we think it's called a square root symbol, but the reason we call it a square root is because we have numbers that are squared. So like 4 squared is 16. And then the square root of 16, what times itself gives you 16, would be 4. But we might also have something like 2 raised to the 5th power. Okay, there's that one that we see quite a bit. So 2 times 2 times 2 times 2 times 2. 2 times itself 5 times is 32. Hopefully you remembered that one. And then if we wanted to take the 5th root of 32, so no longer is it a square root, it's a 5th root. So you're asking yourself, what times itself 5 times gives me 32? And then the answer to that one would be 2. So it's not always a square root. There is like an invisible 2 here at the top, but we just don't write it because it's commonly accepted as a square root. But just know that there are different roots that you can take of numbers. So this is not just called a square root sign. It is called a radical sign. And so you might also hear me reference this as radical 16, which radical 16 is 4. So radical 16, square root of 16, kind of means the same thing. So that is a radical sign. The expression radical x, or the square root of x, is a radical expression. Okay? So not only is that like a square root expression, but again, it could be a different root, so you can just call it a radical expression because that symbol is a radical sign. And then the number, the x that's underneath the radical, so that x right there, it also has a special name. So anything that's underneath the radical is called this. It could be like a 3x squared underneath the radical, and it's called the radicand. So the radicand, not the radicant, the radicand. Okay, somebody let me outside. Okay, so if I were to give you a radical and say I have like 16x plus 4y, like that's all stuff underneath a radical, and that's fine. It's a little complicated, we're not really gonna get into that, but everything underneath there, the 16x plus 4y, that's considered your radicand. Anything underneath the radical. And so there's that. Yes, Bubby. My dog, he wants some attention. Okay, go lay down, go play, go play. Okay. All right, so I wrote up our list of perfect squares. 1 squared is 1, 2 squared is 4. These are the ones that I recommended you memorizing or creating flashcards for. And also the reverse of those. So if I ask you, what is the square root of 1? What times itself gives you 1? 1. And then Next will be the square root of 4. What times itself gives you 4? 2. The square root of 9. 3. The square root of 16. 4. The square root of 25. And so forth. So I'm just going to finish this list. And these are things that I would, again, highly recommend you making some flashcards for. If you don't have index cards, just use scrap paper. It doesn't have to be index cards. But go through them in some of your free time. This does not require internet access. Okay, so you can memorize your perfect squares and your square roots. And this will be very helpful later on, I promise. And it's just a good skill to have, that recognition. So, almost done. So the more familiar with these numbers you become, the better. So the square roots, square root of 1, 1, square root of 4 is 2, all the way down to 15. Square root of 225 is 15, because you're saying 15 times itself 2 times is 225. Okay, so there's that list. You can make yourself some flashcards and practice them. So, the product property. That is something that we're going to be using in order to simplify radicals. So, simplifying radicals is fun. If I have the square root of A times B, okay, 2 numbers underneath my radical, my radicand, A times B. What I can do with that is I can split it, so I have the square root of A times the square root of B. So they each get their own little radical sign. And you'll see why that is helpful here in a second. Let me actually go to example 1 before I do anything with the quotient property. So example 1, this radical is not simplified. And the reason why, the square root of 8, if you were to look at this list, okay, 8, the number underneath there, the radicand, you should be asking yourself, are there any perfect squares? So we're looking at this list here, the first list. Any of these perfect squares that I can divide out of 8? The answer should be yes, 4. So 4 is a perfect square that can be divided out of 8. And so what we're going to do with that is we're going to split this radical expression into the square root of 4, okay, that was our perfect square factor, times, well, what is 8 divided by 4? 2. So all I've done is just rewritten this radical expression and split it apart into 2 different numbers, 4 and 2, but notice they both have their own radical sign. So I'm using that product property there. The A times B in this case is just the 8 right here. And then I split it into the square root of A times the square root of B, which is the square root of 4 times the square root of 2. Could I have split this into the square root of 8 times the square root of 1? Yes. But it doesn't make sense to do that because 8 or 1, well, technically 1 is a perfect square, but by simplifying it, you just get 1, and that doesn't really do anything. So you want to find a factor, a number that multiplies to give you 8, that is a perfect square. That's in that list of perfect squares, because the square root of 4, what times itself gives you 4, is just 2. So now this expression, the square root of 4, becomes a 2. And then this square root of 2, there is no perfect square factor other than 1. We don't really care about 1. That you can divide out of the 2. So it is completely simplified like that. So the square root of 2 does not break down, and you've got your just regular 2. So 2 times the square root of 2. 2 and the square root of 2 are not the same numbers. If you needed to type that into a calculator, you could type it in. The square root of 2 is a number times itself that gives you 2, and it's 1.414, and the decimal keeps going on forever. So that is not just the number 4, okay? You can always check your answers by typing these back into a calculator. So if you did that, let me move this without a comment. All right, let's just put it down. The square root of 8 is 2.828, blah, blah, blah. And then if you were to type in 2 times the square root of 2, you get 2.8222, blah, 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 blah. So the number values of these two are exactly the same, which is a good thing. You want it to be the same. We're not changing the value, we're just simplifying it. We're writing it a different way by taking out a perfect square factor. So 2 radical 2, or 2 times the square root of 2, is your final answer to simplify this radical. Okay, cool, yeah. Let's do number 2 together. Example 2, the square root of 54. Okay, so we are trying to simplify this radical expression. So the square root of 54. The only factors of 54 that we care about are the ones that are perfect squares. So if you're trying to divide 54 by 2, we don't care about 2 because 2 is not a perfect square. Okay, only these numbers in this list right here are perfect squares. So 54. What I would recommend doing, especially once your numbers get bigger, like if you look at number 4, 243, just start dividing them by your perfect squares. If it's a larger number, 243, you want to find the biggest perfect square root factor. So start with your bigger numbers and go down rather than start with your smaller numbers and going up. I'll show you the difference there once we get there later on. But 54, if you were to go through, guess what? Oops, I typed it twice. 54 divides by 9. So 9 is a perfect square factor of 54. So to simplify this radical expression, we are splitting that 54 into 2 factors. The square root of 9 times the square root of 6. Okay, because 9 times 6 is 54. So the square root of 9 times the square root of 6 is the square root of 54. But the reason that we like the square root of 9 is because it's a perfect square. So what is the square root of 9? 3. So this expression gets simplified to just a 3, and then the square root of 6 does not have a perfect square factor, so the square root of 6 is done. So it's just 3 times the square root of 6. And that's your final answer. Again, you could check the decimal value to make sure you did it right. The square root of 54 is 7.34, blah, blah, blah. And 3 times the second square root of 6 is 7.34, same number. By the way, on a graphing calculator, you have to hit the second button, and then the square root is right there by the x squared. On the smaller calculators, it's kind of the same thing. You have to hit the second button first, and then hit the square root button. Okay. I want you to do example 3 on your own. Okay, the square root of 500. Find a perfect square factor that you can divide out and simplify. So you're doing example 3. Example 4. Okay, we've got the square root of 243. So like I was talking about earlier, your list of perfect squares, you want to find the biggest perfect square factor. So 243, I'm going to start with, well, 225 doesn't really make sense because they're a really close number. So does that divide by 196? No. Does that divide by 169? No. Does that divide by 144? No. 243 divided by 121? No. No. Ooh. What you should find is that 243 divided by 81 is a factor. So what this splits into, got my highlighter on there still, the square root of 81 times the square root of 3. And then what is the square root of 81? Just 9, and then times the square root of 3. So there's your final answer. If you would not have found 81 to be the biggest perfect square factor, say you were going through your list of perfect square factors, and you're like, oh, well, 243 divides by 9. Okay? Watch carefully. You're not wrong. You can still get the correct answer. So if I say that this splits apart into the square root of 9 times the square root of 27. So 9 times 27 is 243. That's fine, okay? Because the square root of 9 then is 3, but the square root of 27, that number itself also has a perfect square factor, 9. So 27 divides by 9. So what that radical becomes, you can take this one and split it apart. It becomes the square root of 9 times the square root of 3. So I'm basically like branching off from that. That splits apart into the square root of 9 times the square root of 3. I still am bringing down that 3 from before. And then what is the square root of 9? Well, I've got that 3 from the first square root of 9. And then the square root of 9 is a 3. And then the square root of 3 does not simplify, so it stays the square root of 3. And then I just have 3 times the square root of 3. These 3's are both regular 3's, so you can multiply them and you get 9 times the square root of 3. So notice how we got the same answer in both of these methods. This one just took longer. So finding that biggest perfect square factor first will save you a lot of work. Okay, so find the biggest perfect square factor. Again, not to say that it can't be done this way, but there's a lot of more room for error. If you would just leave it as 3 times the square root of 27, I would count wrong. It's not simplified all the way. Okay. I'm going to do example 6 with you and have you do 5 on your own. Okay, I know we haven't done one like 5 yet, but 6 is similar, but it has that extra step there, so I'm going to do 6, and then you're doing 5 on your own. So 6, we've got a regular old 3 times the square root of 12 times the square root of 6. So this product property also works backwards. So if I have the square root of a times b and we're splitting it into the square root of a times the square root of b, if I had 2 different radical expressions, as long as the radical is the same, like these are both square roots, you can multiply the numbers underneath the radicals and make it one number. So what that means here is, since I have radical 12 and radical 6, I can multiply radical 12 times radical 6, which 12 times 6 is 72. So then I have 3 times the square root, or radical 72. And the reason that I want to do that is because now I just have one number that I'm trying to simplify. So yes, the square root of 12 has a perfect square factor and we could simplify that, but we also have the square root of 6 that doesn't simplify. But when we bring them together and we just have the square root of 72, that's only one number that we're trying to simplify the radical expression for. So again, trying to save yourself some work here. The square root of 72, what is the biggest perfect square factor of 72? So on your list, 72 would be somewhere right here. So start working your way down, okay? Don't go up because you might miss the biggest perfect square factor. So start your way down. What's the biggest perfect square factor that 72 divides by? Hopefully you said 36. Okay, so 36 is the biggest perfect square factor of 72. So I'm just going to rewrite this radical expression. That 3 is tagging along. 3 times the square root of 36 times the square root of 2. What is the square root of this 36? Why do we like it so much? Oh, it's a perfect square, and we get just 6. So 3 times 6 times the square root of 2. These are just regular old numbers. What's 3 times 6? 18. And then we've got our radical 2 tagging along, because that does not simplify. So 18 radical 2, or 18 times the square root of 2, is your final answer. Done. So you're doing example 5. You have a radical 6 times radical 15. Multiply them together. Then you have one number that you will be simplifying, just like we did over here. Okay. Whew. Number 7 and 8. We need the quotient property, because if you notice, we're dividing. So the quotient property is very similar to the product property. So the quotient property, if I have a quotient under my radical, a divided by b, the square root of a divided by b, I can split that up. Just like I could split a product up, I can split a quotient up. That's saying the same thing as the square root of a divided by the square root of b. So again, they both get their own radical sign when you split it. So we're going to use that in our next part here. Example 7, the square root of 7 divided by the square root of 16. So that is a quotient. I can split it and give them each their own radical sign. So the square root of 7 divided by the square root of 16. But you need to make sure you're simplifying as well. Does the square root of 7 simplify? Does 7 have a perfect square factor? No. Okay, so that one's simplified as far as it will go. Square root of 16. What is the square root of 16? 16 is a perfect square. 4. So you get the square root of 7 over 4. And you're done. I want you to do example 8 on your own. The square root of 16 divided by the square root of 25. That one should be an easier one. Okay. Moving on. A square root expression is considered simplified if. So this is what you're looking for to make sure that your square root expression is simplified. So if there are no other perfect square factors other than 1. And so what that is saying is kind of like the example where I did it in 2 parts. So you wouldn't just say that this answer was 3 times the square root of 27, because that radical expression there has another perfect square factor other than 1, 9, okay? So we could break that down again. And so it wasn't considered simplified. But when we went over here, 9 and the square root of 3, our radical didn't have any other perfect square factors other than 1, so it was done. So that's kind of what that first step, is saying. And then step number 2, no radicals can be left in the denominator. So no radicals in the denominator. If you have a radical in the denominator of a fraction, it's not considered simplified, okay? What you should find in example 7 and 8 is that you don't have a radical in the denominator, so it's fine, it's simplified. But I'm going to show you in this next step what to do if you do have a radical in the denominator, okay? It's a process, and I hope you enjoy it. Okay, so the process of removing a square root from the denominator, so right there it is. I'm going to leave that blank for a second. We're going to do an example, and then we'll fill it in. So 2 divided by the square root of 7. The square root of 7 is a radical. First of all, it is simplified. Okay, there's no perfect square factor of 7. So the radical itself is simplified, but it's in the denominator. You can't leave it there. So if we were in class, I would have you guys like brainstorm ways to think of how you could get it out of there and what you could do. But we're not in class, sadly. So we're going to have to go about this a different way. I might just have to plot spoil for you and tell you how to do it. So a very common explanation of what students think to do to get it out of there is multiply by the reciprocal. So I'll show you that. Don't write this down because it's wrong. But if you were to multiply by the square root of 7 over 2, 2 is not a radical, the square root of 7 is, so you would get 2 times the square root of 7. And then in the denominator, the square root of 7 times 2 is 2 times the square root of 7. Well, 2 times the square root of 7 over 2 times the square root of 7 is just 1. It's the same thing over itself. And if you were to type in 2 divided by the square root of 7, you get 0.7559 blah, blah, blah. That's not the same thing as 1, okay? And remember, with all of these, we're just simplifying. So your decimal value should be the exact same. We're just rewriting these all a different way. And so that is not what we do. So what we have to do is we're going to use basically that product property. So 2 divided by the square root of 7. You're going to multiply by whatever that radical is over itself. So the square root of 7 over the square root of 7. Because as we just talked about, anything over itself is just 1. So basically we're taking this expression and multiplying it by 1. So we're not changing its value, we're just changing what it looks like. So your numerators, 2 times the square root of 7 is 2 times the square root of 7, okay? But in your denominator, the square root of 7 times the square root of 7, okay? Remember, they're both radicals, so you can multiply the numbers underneath. You get the square root of 49. And what's special about the square root of 49? Bing! It is a perfect square. So the square root of 49 is just 7. So then you get, in your numerator, 2 times the square root of 7 divided by 7. What you should look for when you have to follow this process, is your numerator simplified now? Is that radical simplified? Are there any other radicals? No, okay? And the regular numbers, if I were to cover up that radical, 2/7, does that fraction simplify? Excuse me, I'm sleepy. No, okay? 2/7 does not simplify, so that is your final answer, okay? Kind of treat them separately, like radicals are their own thing and regular old numbers are their own thing. Okay. I want you to do example 10 on your own, but make sure you're watching carefully as I do 11 with you. So, example 11. Because these can be kind of difficult, I'll give you that, because there's lots of different steps you could do first, all to get the same answer. So again, it doesn't hurt to make sure that your answer is the same decimal value. So here we had 2 radical 7 divided by 7. And if you type that in, 2 radical 7 divided by 7, you get that same decimal answer that we started with, 2 divided by radical 7, excuse me. Okay, so you should still get the same decimal answer. That's one way to check your work. Number 11, the square root of 4/32. Okay, so it is a fraction. You can split it. So the square root of 4 over the square root of 32. Okay, what you can notice is that you have a square root of 4 in your numerator. That's a perfect square. So you can simplify that right away, or you can simplify it at the end. The square root of 32. What you should know about 32 is that it probably has a perfect square factor and can be simplified. Before, our square root of 7 couldn't simplify and we just went with it. But the square root of 32 and the square root of 4 can both be simplified. So you can either simplify at the end or simplify at the beginning. So we could start by multiplying by the square root of 32 over the square root of 32. I'm actually going to do this one both ways so that you can see the difference there. Or you can simplify first. I'm going to simplify first. So you end up getting 2, and then the square root of 32, the biggest perfect square factor of 32 is 16. So that's rewritten as a square root of 16 times the square root of 2. Okay, and then, well, what is the square root of 16? It's 4. So I get 2 divided by 4 times the square root of 2. Okay, but I still have a radical in the denominator. Yes, you could simplify the 2/4 right here, but we also have a radical still. So if I wanted to, forgot what, we didn't fill out what this process was called. I was going to tell you. I'll come back to that. We still need to multiply by the square root of 2 over the square root of 2 to get that radical out of the denominator. So that's the next step there. Multiplying by the square root of 2 over the square root of 2 to get that radical out of the denominator. In my numerator, then I get 2 times the square root of 2. In my denominator, watch carefully. This square root of 2 times this square root of 2 gives me the square root of 4, which the square root of 4 is 2. But I still have that 4 tagging along. So I've got that 4 times the square root of 2 times the square root of 2, which is the square root of 4, which is just 2. A lot going on there. So that gives me 8 in the denominator. So bring that down, I have 2 radical 2 all over 8. Actually, let me show you that step. So I have 2 radical 2 over 4 times radical 4, which is 2 radical 2 divided by 4 times 2, which is 2 radical 2 divided by 8. Okay, lots of steps here. Radical in the numerator is simplified. There's no radical in the denominator, but that outside fraction, 2 divided by 8, you can divide a 2 out of both of them. So you get the square root of 2 over 4. And that is your final answer, okay? You don't simplify the 2/4 because it's not 2/4. It's a square root of 2 over 4. There's a square root there, okay, over 4. So then it's done. Again, that decimal value should be the same as what we started with. If you were to type in the square root of 4/32 and the square root of 2 over 4, you should get the exact same decimal. So that looks kind of crazy, right? One thing that I want you to understand about simplifying your radicals like this, in the denominator, by the way, the square root of 7 is what kind of number? A decimal that goes on forever? Irrational. And so when we're following this process to get it out of the denominator, 7 is a rational number. So that process, going back up to that bullet point there, this is called rationalizing the denominator. So rationalizing the denominator. Trying to put a rational number in the denominator because it's most likely irrational if it has a radical there. Okay, so that's what the process is called. And when you're doing that, every time, so we had the square root of 7 times the square root of 7, which is the square root of 49, which was just 7. The square root of 2 times the square root of 2, which is the square root of 4, which is just 2. So what you should notice is like the square root of 5 times the square root of 5 is the square root of 25, which is just 5. The square root of 6 times the square root of 6 is 36, which is just 6. The square root of 10 times the square root of 10 is 100, which is just 10, or square root of 100, which is just 10. So when you're rationalizing the denominator and you're multiplying a radical by itself, you're always going to get just that number. So you can skip that step, okay? Like here, I had written the square root of 2 times the square root of 2 is the square root of 4. I could have just skipped that and said the square root of 2 times the square root of 2 is just 2. Okay, so you can skip that step. Hope that made sense. There's a lot going on here. Let me show you the process of doing this now by waiting to simplify at the end. So I simplified first. Let me show you that simplifying at the end. So I'm going to bring this over to the side. Square root of 4 over 32. Okay, so I split it first, and now instead of simplifying anything, I'm going to just multiply by the square root of 32 over the square root of 32. So my numerator becomes 1 times 32, the square root of 128. My denominator is the square root of 32 times the square root of 32, so I'm going to get just 32. So now all I have to do is simplify that radical in the denominator, 128. I want to find my biggest perfect square factor of 128, which would be 64. So that splits apart into the square root of 64 times the square root of 2 all over 32. And then what is the square root of 64? 8. Okay, so the radical is no longer in the denominator. I'm simplifying this giant radical that's in my numerator by finding the perfect square factor, the biggest perfect square factor. And then the square root of 64 is 8. 2 does not simplify. And now all I have to do is simplify that outer fraction. What's 8 divided by 32? What's the biggest number you can divide out of both 8 and 32? Well, it's 8. So in your numerator, you're just left with the square root of 2, and then in your denominator, you're left with 4. So 8/32 is the same as 1/4. Technically, there's like a 1 up there, but you don't need to write it. And so then there's your final answer. What do you notice about this one compared to the other? It was a lot faster. And so you'll have that sometimes. All of this red compared to that blue. So again, it doesn't matter which way you choose, simplify at the beginning or simplify at the end. If you notice though, the only difference was here we were working with larger numbers. So if you can work with smaller numbers, simplify first. If you don't mind working with larger numbers, simplify at the end. I want you to do example 12 on your own as well. And then in the next lesson, we'll actually use properties of square roots to solve quadratic equations. All right, I know that was kind of a long one, but there's a lot with radicals that we could do. Again, just always double check the decimal amount to make sure that you've done it correctly. And I hope you have a great day. Bye.